Welcome back. Ready to crush your AI interview? Walk me through a minimal agent loop. What components are required for autonomy? At the core, an agent loop is just a repeated cycle of observe, decide, act, and update state. You don't need a giant framework to get autonomy. You need a few very specific components wired together carefully. The first component is perception or observation. This is everything the agent can see at a given step. That usually includes the user's role, the current conversation, any intermediate results from previous steps, and the outputs of the tools. The key thing is that this observation is explicit. If the agent can't see it in its input, it effectively doesn't exist. Next is state or memory. This is what lets the agent behave consistently over time. At a minimum, this is a short-term scratchpad where the agent can record decisions, partial results, or constraints. In more advanced setups, this includes long-term memory stored outside the context window, like a database or a vector store. Without state, the agent just reacts. With state, it can plan and adapt. Then you have the policy, which is usually an LLM prompt plus some control logic. This is where the agent decides what to do next. Given the current observation and state, the policy outputs an action. That action might be call a tool, ask the user a clarifying question, or finish and return an answer. This decision step is what gives the agent its autonomy. The next component is the action interface. This is the set of tools the agent is allowed to use and the rules for using them. Tools might include search, calculators, APIs, or code execution. Each tool has a well-defined input and output. Most importantly, the agent can't just do anything. Its autonomy is bounded by the tools you give it. After the action is executed, you have an environment response. The tool returns a result or the world changes in some way. The output is fed back into the agent as part of the next observation. This closes the loop. Finally, you need a termination condition. The agent must know when to stop. That can be explicit, like the policy choosing a final answer action, or implicit, like hitting a step limit or detecting that the goal has been satisfied. Agents without good stopping rules tend to loop, overthink, or spam tools. So the minimal loop looks like this. Observe the current state, decide on an action using the policy, execute the action via a tool or response, update state with the result, and repeat until a stop condition is met. Thanks.